Ms. Maria, and I'm from the JobWeek project. So today I'm going to introduce you an ERP tool that not only covers the data visualization and analysis of all different areas of a business, but also ensure the non-functional requirements, including the security, availability, and the interoperability for a long-term scalability and growth. So our website has two roles, the HR and the employees. So because both are the employees of a company, so that they can use our website to visualize the company's different kinds of data sets and ask for the leave request. And beside that, the HR role, aka the admin, is also responsible for the employee management, including creating the new employees with a new account and manage the leave request of the employees. And in this version, it doesn't include a conversations interface to let users talk with the data, which is the only difference from the original project proposals. And we also have built an architecture that can protect the business data from external parties and also make it able for each module, like employees, HR, and data, can communicate with each other. And we also try to isolate each users so that one's fault cannot affect the others and also affect the whole system. And we will try to keep our websites alive 24/7. And we don't forget to implement the authentications and the authorizations for every users from each row. And we also did some simple testing to make sure that our data flow is tested throughout the system from internal and external source. So let's jump right into our architecture design. So first of all is the container diagram. So we choose the container-based microservice architecture for this one because this is where the microservice runs in the containers defined by the task on AWS Fargate serverless infrastructure. And the flow will start at the users will access the website using the business account, and then the front-end service will receive the user request and send it to the backend service. The backend service then asks the database for data to process the user's request and then return the data back to the front-end service. And then the front-end service will receive the data from the backend service and then render the UI with the data for the users. So the reason why we choose this kinds of architecture is, first of all, you can see that each container are isolated from each other, which means that a failure in one service won't bring down the entire applications, so that the system still be available even though something is broken down. And moreover, each microservice had its own container with its own set of dependency. So if one service is compromised, the attacker's access is limited to the specified container, which means that the data in the areas other than the area under the attack is still protected. Next is the component diagram for front-end service. So we use a framework called Remix for our front-end development. And the Remix, it doesn't strictly follow a single architecture design pattern, but it incorporates many aspects of several patterns to create a full-stack web development framework. And the flow will start at the users interact with the web applications and the client, and then the client will ask for the appropriate route from the route, and then the route will access Remix via hook to integrate Remix specific functionality into the React components. And next is the authentications will be done at the sessions, and after that the sessions will ask for the role page data to render the UI content of a web page via the server side render, which is the SSR. And the SSR then retrieve the data from the backend service and then render the whole web page to the users. So the reason why we choose this kind of framework, because first of all, it offers the built-in support for the TypeScript, which is our main tech stack for the front end, so that we can easily learn and approach this framework. And next, it provides the built-in section management with the cookie base and all the server-side storage options. And this allows for secure user authentications and authorizations within our applications. So which means that it ensures every rows only have access to the part of the system that are relevant to them in their session time, like the user space authentication system will be isolated from the public internet. So for the backend, the backend is based on the MVC design pattern, and the individual layers are decoupled from one another, but are deployed as a monolith. And also the securities could be split into the separate microservice if the scope of our project is broadened in the future. So the flow will start from when the users interact with the front-end application, which sends the API request to the backend, and the request will reach the controller layers of the backend. So the controller will first validate the user's access token using the OAuth mechanisms. If the authentications and the authorizations are successful, the controller will interact with the model layers to process the request data. So the model layers will retrieve the data from the database and manipulate it, and then the controllers can generate a response based on the processed data and the view schema definition with formatting the response in JSON. And then the controller will send the JSON response back to the front-end applications. So the reason why we choose this kind of architecture is, first of all, MVC is a really easy to learn model. And second, the model layer of it can encapsulate the data access logic, making it really easier to control and secure the database interactions. And moreover, the MVC models have the separations of the security logic within the controller layers. So this allows for centralized management of access control, so that if there are any suspicious access, it will be prevented at the controllers. And also the separation of each components allow for easier interactions of different data multi-source presentation layers, which means that we can easily integrate other components from other modules and integrate data with other business tools in the future. So our website is deployed on the AWS web service, and this deployment diagram follows the modular three-layer architecture, showing how the components are deployed across different servers or cloud environments. So first of all is the ECS cluster. So the ECS cluster will manage and orchestrate the containerized front end, which is the front end ECS Fargate, and the back end, which is the back end ECS Fargate service of the applications. And the front end load balancers is used to distribute the incoming users traffic to the front end ECS Fargate. And the backend load balancers is used to distribute the traffic for the backend logic to the backend ECS Fargate. And both ECS Fargate service communicate with the database to store and retrieve the data required by the applications. And the database is deployed using the Amazon RDS. So the reason why we choose this kind of architecture is, first of all, the ECS Fargate can automatically scale the container deployments based on the traffic demands, which can handle a really high volume of the traffic. And moreover, the load balancers distribute the traffic across the healthy instance, which can ensure the applications remain accessible even if the individual front-end or back-end containers fail, which make our system still available for 24/7, even though something is broken down. And each container is isolated so that the phones in one doesn't affect others.
So let's jump right into our website. So welcome to the home page. And this is the introduction page of the project. And let's meet our team members. So we will start at logging in as an admin, which is a member of the HR team. So you can see that in the dashboard, it has some data about the business, like the total employees of the business, the total data sets of the business, and also the charge that the business has created, and also the list of the employees. And as an HR, we can like see the list of the employees, and we can do some adjustment on the employees, like we can change the department of an employees, such as I will change this into marketing. And you will see that Manway has changed from engineering to marketing. And we can also like delete employees using this feature. Yeah. And we can also add the new employee. Yeah, I will add this one. Select the department, marketing. And I will create like the new Excel for this one by entering the username and the password. Okay, start with day of work. This one. Yeah. Employees and sales person. Yeah. And then you can see that the email has been hacked into the link. So then I will try to log in with the new account of the new invoice. Okay, and this is the website for the invoice. So the difference between the HR and the invoice is the invoice doesn't have the HR here. Let's jump right into the main functionality of our project. So the dataset, so this is the dataset, these are the dataset of the business. And you can see the dashboard of this dataset and see the statistics data of it, like such as this one, this is the dashboard about the cloud cost. And you can see the data of the sum of monthly cost, the average cost, the minimum and the maximum cost, which is calculated from this dashboard. And we can also upload a new dataset. So let me just use this one. Enter intersegment sales minimum. And then you can see that a new dataset is added. And let's create a chart for this one. So you can see that this is the table from our table size, and you can enter the chart name, like, because I want to see the sales, like which products has the highest or the lowest sales of this month. So I just type here, chart name, and then I will choose the project. And this one will be the product name, and this one will be the total sales of each product. And you can see that a chart is generated. And click here, chart. Yeah, and then you can see that a new chart is created. And you can also see the statistics data of this one, like the total sales of this month, the average sales, the minimum sales, and the maximum sales. And besides that, we can also like delete the dataset if we don't use it anymore. Like we try to delete this one. Yes. Yeah, and next if if he wants to create a new request, he can go to profile And you can see that the list of the leave requests of these employees, and then we create a new one. Yeah, pick a day start, and the day end, and you choose a reason, and then create. So you can see that the new leave request is created, and next I will log into the HR account to approve or deny this leave request. Okay, then we will go to HR and time of request. And you can see that this is the list of every list request from the employee. We will like approve or deny, like we can approve this one, the new leave request, and we also can deny a leave request.
The proposal presents 3 non-functional requirements for JobWeek, of which security is the first and most important. The project comes with an automated test suite, which creates an in-memory database to statelessly test the security ASR. You can see here that a number of text fixtures replicate the user logging into the application through the test client, and then a set of tests check each endpoint with and without the authentication token. The tests themselves can be run with a simple PyTest invocation, and you will notice that all of them pass. If we now look at the endpoints, each of the endpoints require authentication by a dependency injection on this getCurrentUser function, which in turn implements the OAuth2 user password bearer token strategy. The dependency injection limits coupling and allows authentication to be switched out in the future with a new system, especially when the inclusion of single sign-on. Security logic is constrained within the security.py file, which can be separated into a separate microservice in the future. Availability is a second non-functional requirement and is effectively achieved through the application's deployment. Both backend and frontend services are deployed in isolated Docker containers on an AWS Elastic Container Service cluster based on Fargate, which separates each service from any one physical host machine and thus reduces the likelihood of downtime. Secondly, the services are also placed within autoscaling groups to ensure that there is redundancy and compute capacity available at times of higher load when availability is important. The resource map on screen depicts the configuration of an elastic load balancer for the backend service. Given the stateless nature of the backend and frontend services, and the autoscaling policy shown before, when taken with the load balancer shown, JobWeek's architecture will effectively scale horizontally for redundancy and performance. Finally, the application database is deployed on AWS RDS with replication and automated backups, ensuring that the failure of any one service, or even of the main database instance, does not cause any downtime or loss. Although not implemented, load testing with tools such as K6 could be used to quantify this ASR. The third non-functional requirement was interoperability. Although interoperability wasn't directly tested, much effort was put in to ensure that the architecture would allow the core of JobWeek to easily communicate with other modules and applications. The most prominent of these is the industry-standard REST API for the backend service, which encapsulates authentication and data manipulation. Each endpoint in the backend is accompanied by a defined request and response schema, which is accessible to humans through the Swagger UI, and through machines through an open API specification. A major functional requirement of the project was the ability to ingest arbitrary data for processing. JobWeek achieves this by accepting and storing any valid JSON dataset input by the user. Currently, the user-facing frontend only supports uploading CSV files, but the flexible JSON endpoint means that the application can easily ingest data in a variety of formats that can be readily transformed to JSON from both humans and from other programs.
This project, besides having a complete website, we also gain so much knowledge from this real-life project. Like for the front end, we will introduce a new framework called Remix, and we have learned about its components like the SSR, the route, and state management. And we also learned how to like cooperate with the AI like Vercel, Nivo, Sassy, and UI to simplify our UI works, and it saves us a lot of time. At the back-end team, we have learned a lot about working with the database, like database design, database engine. We have to manage the sessions and perform and integrate the CRUD operations with fast APIs using Cycle Alchemy. And we also learn how to perform some simple API testing. And for the deployment, we also learned how to deploy our project on AWS using EC8 cluster, AOB, and Fargate. And we also learned a lot of knowledge about them because we have to read a lot of AWS documents. And about the architecture, so this is our first experience that we have to design architecture for a whole system based on both functional and non-functional requirements. And also we have to consider the characteristic of the project, like the size, the team members' knowledge, and also how many times that we have to build this project. And even though our architecture is just a really simple one, but this is a really precious experience. In conclusions, the team has a chance to perform different roles while building a whole simple projects, but just by ourselves, because we have to handle all of the jobs relating to from designing to developing to deploying and to testing.